All right, so for all of my algebros out there, we're going to start to take a look at some of these ellipse style questions here. I wanted to go over this guy first with you just to define something unique about ellipses. So you'll see here that it says that in the center of a large shopping mall, there's a pool with a small sailboat floating in it. There's the sailboat. The boat is held by a 4 meter long cord tied to a ring, which is attached to the bottom of the boat. The cord is fixed to two posts, A and B, which are 2 meters apart at the water surface. So write a rule that will describe the region inside which the sailboat can move. So here's a weird component of ellipses that makes sense once you understand the nature of any ellipse. So if I have an ellipse that looks like this, okay, and I choose any point on the exterior of this function, okay, if I added that length to that length right there, okay, it would be equivalent to that full length right there.
Do you have this sheet?
Yep, you should. So check right in front of you if you don't have it. It's that one right there on top. So it's going to be the major axis. So every time you see that, it's going to be the major axis, okay? So it could be any point, right? Like I could be looking at just right down here. If I added this length to that length, it's also going to be the length of the major axis. So this style of question, basically what it means is if I were to pull this string tight to the edge, okay, then my sailboat, right? So let's just draw that there. Then my sailboat would follow that boundary right there. Does that make sense? Like if I just kind of grabbed that, pinched it, and kind of went all the way around, if I kept that string as tight as possible, it would form the shape of that ellipse. Does that make sense?
Yeah.
Okay. So that's the very nature of like these guys here, is that if they've told me that this chord here, so this chord is 4 meters long, that means that my major axis is equal to 4. Okay? It additionally pointed out that the distance between A and B, so that full distance, is 2 meters. Okay, so let's break down what we have then. So underneath this guy, let's just do one drawing here. Okay? So this is 2 meters. Okay? This distance is double whatever C is. So instead of writing 2C, I can write double C. Meaning that if I just cut that in half, from the center to a foci is 1, from a center to the other foci is 1. So for all of these questions, it's important to start with like writing down your ABCs. What are the pieces of information that you do know? Well, in this case, because they said the total distance between the both posts is 2, that means my C is equal to 1. Any questions on that? Need me to explain that again? Okay. The fact that 4 meters is the length, so that means major axis is 4. So if major axis is 4, what did they actually just give me? Think about that one for a second. If the total, what they're saying, if the total, so if I draw this again, and they're saying that distance there is 4 meters, what did you now just get? Okay, so this, yes. So then that means if that's 4 meters, then I know my A value. What did I just do wrong? Why is it not 4? What is it? It's 2. Because the major axis is basically saying from here to here would be half of the total distance. Okay? So that makes my A value 2. So if you have to sketch it out, you can. I don't think you need to. It's just more me for explaining purposes why I drew it the way that I did. Okay? So right now, I now would go to my memory aid and I'm going to identify, hey, this guy is a horizontal guy. Okay? Meaning if it's horizontal and I'm looking for a missing piece, I'm going to use this modified Pythag. A squared is equal to b squared plus c squared. Because this guy is the hypotenuse in this case, right? So hypotenuse squared. So I'm looking for b in this case. So let's actually do that. So let's, step one, find b. So I'm going to use a squared is equal to b squared plus c squared. And we're just going to plug everything in that we know. Plus 1 squared. So I'm just going to rearrange and solve for b. So 4 is equal to b squared plus 1. Bring that guy over. B squared is equal to 3. So b would be equal to square root of 3. But also, you can kind of freeze here on these ones. I don't really care about solid b. I'm actually really only looking for b squared, and I'll show you why. The whole question was asking me to find out the rule that defines this situation. Well, I know it's an ellipse, so that means right now this is going to be the rule. X squared over a squared plus y squared over b squared is equal to 1. All right, so if x squared is over a squared, well, then when I go to write this out, x squared is going to be over 4 because I'm just going to take my value for a and then square it. And for y squared, I'm not going to write square root of 3 squared, right? I'm just going to write 3 squared. Okay? Or not 3 squared, I'm just going to write 3. Sorry. Because the two, like this and this, they cancel each other out. So I don't need to write the square root of 3 squared. Doesn't make any sense. The square gets rid of the root. So then that would be my final answer for that guy. This whole purpose was find a rule. So this is just baby steps right now, finding the rule of an ellipse in a weird situation. So I'll let you copy that down real quick, and then we'll start on the next guy, which is a bit more challenging. Hopefully you don't see this guy on a test, but it's still good for you to know. Still good for you to know. So I'll leave that up for a couple more seconds. And you can just fast forward to this part of the video. So this one is a bit difficult, okay? And just in terms of the way that we want to think about it and approach it. So Michael wants to take part in an airplane race around 2 pylons, the tops of which are 2 kilometers apart. So right now I'm going to write A, B, C, okay? To have the best chance of winning, he estimates that the sum of the distance separating him from the pylons should always be 3 kilometers. So the sum of the distances separating him from the pylons should always be 3 kilometers. Okay, so that's an interesting way to kind of phrase that. I want you to just try and decode what that means yourself. And I'm going to end this video here. And I'll have you, because I want you to try and work on the decoding yourself. So I'll give you a chance to work on this guy. It's a little bit of like a weird case. So we'll finish this one in class.